Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to part 22 for our Godot Action RPG series. This is the real final part. This time, I didn't forget anything. This will be the last video. And in this video, we're going to be implementing some simple sound effects into the game. And we're also going to be adding the flash animation for our player and our enemies. So let's get started. The first thing we'll do is start implementing some of the sound effects. And actually, I think my recording software is doing desktop audio, so I'm going to turn that down just a little bit so that we can hopefully make sure that these sound effects aren't too loud. Let's come into our player, and we'll add a new node, an audio stream player. And don't do audio stream player 2D. My understanding is that the difference between a basic audio stream player and the 2D one is that with a 2D audio stream player, you can have sound effects happen basically relative to their position in the world. So the closer you are to that sound effect, the louder it will be. And we don't need that for this game. So we're just going to do a basic audio stream player like this. And we'll come into our animation player. And on our attack down here, we can, let's zoom in just a bit. We can add a new track, do a new audio playback track, and select our audio stream player. Then we can come over to the first key, and we'll insert a key here, and then click on that key, and we need to tell it what sound to play. It's called the stream over here. And we can come into our music and sounds here, and we'll choose our swipe sound, this. Now you can see when we play the animation, it should play this sound effect. I'm going to watch how loud it is on my recording software here. Okay, that was pretty loud. I'm going to quiet it down just a bit. There, that should be good. Okay. Now we're going to do that with the other directions. Add track, audio playback, add a new key, and then drag over our swipe sound effect again. And we'll do it with right as well. And we'll do it with up. There we go. We've got swiping in every single direction. We're going to add some sound effects to some of our actual effects as well. So come into your effects here, come into your enemy death effect. We're going to add a new audio stream player to this. Oops, I did 2D. Try this again, audio stream player. Do not do the 2D one. And we'll drag over the enemy die sound effect right here. And we'll check autoplay so that it plays automatically. We can close that. We'll come into our hit effect as well. Add an audio stream player, and we'll select hit and turn on autoplay on that as well. Now, if we play the game, we'll be able to run around, hear our swiping, and here a nice little hit effect and a death effect for our enemies. Hopefully that explosion effect isn't too loud in my recording here. It's pretty loud. I think I'm going to turn down my audio just a bit more here to try and help make sure that this isn't too harsh on you guys' ears, especially if you're watching with headphones. Okay, so we've got those in. Let's add in for our roll animation as well. So do roll down. Come into here, add a track. We'll do an audio playback. We can select the same audio stream player for this, insert a key, and now we'll use the evade sound effect like this. There we go. Okay, and we can choose left. Follow the same process. Right. And one of the cool things about this is you can see the sound effect down here in the animation player, you can actually drag it around too, which is super cool to me. You can drag it around in your timeline and move the key. Okay, roll up. We got to do this one too. And there we go. Let's see. There is one more sound effect we want to do here. Let's see. Let's run the game first. And interesting. We should also have a sound effect when the player gets hit. Make sure that's working. Uh-oh. We've messed something up. Let's come into our attack. Let's see, we want to come into our attack down. And we want to go all the way to where our collision shape is disabled. Our collision shape was being enabled because we had it set to this right here. So, well, you don't have to do that either. We could just go, we want to set this back to idle down anyways. And then we can just come into our sword hitbox and we can come into the collision and just disable it right here outside of the animation player. Okay, there we go. Now we can see the bats are damaging us. So there's one more sound effect we want to do, and it's when the player takes a hit. We want the sound effect to be, we'll have the hit effect still, but we want to layer another sound effect on top of it for when the player gets hit. Now, we could add a sound effect here to the player scene and have it play that sound effect when we take a hit, right? But the problem is with that is that if the player dies, it will destroy that sound effect player and it will cut off the sound effect. And so it'll destroy the node, it'll free the node when the player dies, and it'll cut off the sound effect. Now, there's two different approaches to this problem that people will use. I asked about it on Twitter a while back, actually. And the two main approaches that people will use is they'll actually have like a dying state for their character, and they'll put the character into that state while the sound effect plays, and then once the sound effect has finished, they will then destroy the character. And they'll just hide the character when it's in the dying state. Now, I don't really like that approach because I don't like to have the character actually in the world still, because then the enemies will still be trying to chase it and attack it and all these things. The other approach that you can do, and you can find ways to work around all those problems too, but I feel like there's a lot that you have to deal with, and I don't like to have to deal with all that stuff. So the solution that I came up with, well, that other people have come up with as well, is just to create a player hurt sound effect, like a scene for it, and then instance that scene into the game world. So if we create a new scene here, we can choose other node and do audio stream player, and we'll call this player hurt sound, and we can attach a stream player to it. So we'll grab the hurt sound effect here, attach it, and we can have it autoplay right here, and then we can just connect this audio stream player finish signal to a receiving method on here, and we can just choose cue free, and hopefully this will work. Scene does not contain a script. We shouldn't need to do a script. We should be able to, if we do connect, let's see. It doesn't seem like we're going to be able to do this. We could use an animation player too. I'm just going to attach a script to it. We'll save it inside of player right here. We'll attach a script to it. And then inside of our ready function here, we can just connect the signal manually, I think. So we'll say connect finished self cue free, like this. We'll just do that. This should work, I think. Connect returns a value. We can ignore that because we don't need the return value. Okay. Also, that's another thing to mention, is if you do have
Warning messages, they list them as errors, but they're just warnings. That's why it's yellow instead of red. You can click on these individually and then ignore them. So for example, with delta here, it's not being used in this argument. So you could put an underscore under it if you don't actually need to use it. Yeah, it looks like we no longer actually need that one in this case. So that's why they have the warnings, is so that you can see whether or not you still need them. Like the attack state doesn't need delta, the roll state doesn't need delta. So we can actually remove these from there. And there we go. This one right here, however, we can't remove this because this argument is passed in from the signal. I think we can just do an underscore on it, and then it will ignore, even though we're not using it, it will ignore that we're not using it like that. So you can go and do that with all of these different warnings that you get if you want to clean up your warnings as well, and that's a good idea. But here we go, we've got the player hurt sound. Now we can just come into the player, and when we take a hit right here on the player, we can, we'll need to actually get access to it up here. So let's do const player hurt sound. We'll preload it, and we'll just come into player here and drag this scene, drop it right here. Okay, and then we can just instance it inside of our world. And we'll come into when we take a hit here, we'll say var player hurt sound equals player hurt sound dot instance. And then we can do get tree dot current scene dot add child. We'll add our player hurt sound. Player hurt sound. I must have added an S to it up here. Let's remove that. What? Oh, it's in the variable, right? Okay, there we go. And I think since we already have it set to autoplay, that's all we need to do. Right? We turned autoplay on. Let's make sure that that works. There we go. So we're getting the player hurt sound, and on the last hit, you can see that it continues to play that sound. If we check our remote scene, we shouldn't see any of them in the world because they did manage to get freed when the sound finished playing. So that's what you can do for that situation. I feel like that's the way that I like to approach it. And everyone has kind of their different method. When I asked on Twitter, I got so many different responses for how to handle sound effects like that, and this is the one that I decided to go with. So there are other ways to do it, and they're not bad as well. So if you have a way you prefer, you can do that. So let's get started with the blink animation. So we're going to come into our player here. We'll come into our local scene, and we're going to add a brand new animation player. And the reason it needs to be a new animation player is because we want it to work on top of our player's existing animation player. So when we play this, whatever animation in this new one, we want it to play that animation on top of our old animation. So you can actually stack two, and you can be playing two animations at the same time, which is really interesting to me, actually. We'll call this our blink animation player. Like this, we'll give it two animations. We'll give it a blink. We could give it a start. Let's give it a start animation. We'll make this 0.2 long. And we'll also give it a stop animation. And we'll make this one 0.1 long. And this is going to be for our blinking. Okay? But we need to actually make the character blink. And you can do this there's a couple ways to do this. You can alter the modulate property by setting raw to true and then maxing out a bunch of these values. That is weird to me. That method also feels like it's kind of like finicky, but the other method you can do is by making a shader and using a material on the sprite. And I feel like that is the method that I would like to use because first of all, it gives me the chance to talk about shaders and to teach you guys a little bit about shaders in Godot. We'll just cover the very basics though. So first, let's come into our player's properties. We'll click on the sprite, come over and select the material and do new shader material.
Okay, so we can attach a shader material. And then we want to click on this and we need to do a new shader. So we'll do new shader inside of here. Okay, and then click on that. And that will open up a little code box down here. And it's really great that the code is down here because as we manipulate this shader, in fact, let's right click here and do edit. This will bring the shader so that all we see is the shader properties here. We're going to click these little object properties and do save as, and we'll just save this in the default path, the res up here. We'll call this white shader. Let's see. White color shader. White color shader. We'll save that, okay? So we've saved that shader now as a resource. We can use it in different places. We use the little icon right here for the shader. So in Godot, it has its own shading language. And this shading language is pretty easy to learn, but it is different from GDScript. So GDScript is based off of Python. Godot's shading language feels more like a conventional language like C, C++ or something like that. So although it's more simple than C++ in the way that it works, but you do have to define all your types. So the first thing we have to do is tell Godot what kind of shader this is. And you can see down here, it says expected shader type at the beginning. Valid types are canvas item, particles, and spatial. So particles are for your own particle shaders. Spatial is for 3D. The canvas item is for 2D. That's what we're going to be doing here. So shader type, and then you just type canvas item, and then you have to have a semicolon. Okay, so once again, this is different from GDScript where you don't need semicolons. We have to have one here. So then we need a function in here in this canvas type, and there are different kinds of shader functions, and they're listed in the documentation. The specific function we need is called a fragment shader. So void fragment. Now void just means that this function doesn't return anything. And this is a built-in function inside of the canvas item shader type. And basically what this does is this little teeny function right here executes on every single pixel inside of our image here. And that's one of the powerful things about a shader is that we're able to do that. So this function, however, even though it says it doesn't return anything, it has a value at the end that you need to set, and this is the color. So for example, if we set our color here to vector for 1.0, 1.0, 1.0, and 1.0, and then do a semicolon at the end, this is going to set every single pixel inside of, let's actually hide our, let's hide all these collision shapes here. It's going to set every single pixel inside of our image to this color right here. And this color is a red value, a red, green, blue, alpha. And so each of these values represents one of those colors, red, green, blue, alpha. So if we set our red to 1, our green to 0, and our blue to 0, but left our alpha at 1, we're going to get a red square, right? Because this color right here is just maxed out on red and nothing on the others. But we actually want to use white, right? Well, this isn't quite what we want because we don't want our character to become a giant white square when he's blinking, right? So what we're going to do here is we're going to create a new variable. We'll call this previous color, and we'll set this equal to texture. This is a function inside of the shader language, and this function takes it basically accesses a pixel on the texture, and we have to tell it which texture we're going to access. Well, that is texture, everything uppercase. This texture that we're telling it which texture we want to access, this is the, so basically this function goes to our sprite and it looks, or it goes to a texture, which in this case is going to be our sprite, and it looks at a specific point on that sprite, and that's the next thing we have to pass in is the UV value, which is just kind of like an XY position on this sprite. and it will give us the color at that specific position on this texture. So this is the color of our current image here. This right here, this previous color, is actually the color. And so if we set color here, it's easiest to just show you. If we set our color equal to previous color, you can see that our shader, what it does here is it steps through each pixel, and it says what color is on at this pixel, at what color is this pixel at this position on our texture. It says, oh, that's clear, you know, it's transparent. It goes through each one until it finally gets down to here, and it goes, oh, this one's actually black, so then it sets it to black, and then it goes through each. This is each individual, like I said, this function gets run on every single pixel, and each time it gets run, it gets the exact color of that pixel and sets the output color to the color that was already there. So this shader literally does nothing except get the color that was there and set that to our new output. Well, we don't want that. We want to have our own mixture of the two, right? We want to be able to mix the alpha value that we have with the white color that we want. So we'll do vec4 here, make a new color, white color, and we'll set this equal to vector 4, and the first three values will just be 1.0, 1.0, 1.0, okay? But the alpha, for the alpha, we want to use the previous color alpha so that it's not transparent when we're on the image, but it is transparent when we're out here. So we're going to do previous color dot A. You can see it's got all of these different ones here. We've got red, green. We scroll down. We've got red, green. Well, this isn't showing. Since it's a vector 4, it's just giving it variables here. But we can do A for alpha here. Okay? And then do a semicolon. So basically, that will select the alpha value of this color. And then instead of setting our output to previous color, we'll set it to white color. And now we get a white character like this, where it's completely white. So we can set this, we want to be able to control this shader with the animation player. And the way that you can do that is by using what's called a uniform variable. And so a uniform is kind of like, you know how in our player we did export variables up here? And we could export a variable and that would allow us to change it inside of the editor. In a shader, let's double click on our shader here. In a shader, that is called uniform. Uniform, and this will be a Boolean, so it's going to be either true or false. And we'll set active equals true. Okay, so we're creating a uniform value here. That means when we're inside of our shader, we can actually see that value. So if we come to our player sprite right here, and we come down to our material, if you come to shader parameters right here, you can see the active variable and we can turn it on and off. But we need to make it so that this active variable is used to set us either to flash white or not. And there's ways to optimize this, but I'm intentionally going for the simplest method that is slightly less optimized, because you really shouldn't you want to avoid using if statements inside of shaders. But in this case, it'll be fine. I'm going for the simple version here. We're going to create a new vector 4 here called new color. And by default, we'll set this equal to previous color. And then our output will set to new color. Right? So that's going to make it so that our shader is just showing the value that the colors that it was set to before, because we get the colors right here. We set our new color equal to those, and then we just output our new color. But we can add an if statement here. We can say if parentheses active is equal to true, right? If active is true here, then we can set new color
equal to white color. And do a semicolon. Okay, there. So now when active is true, and let's set it to false by default. When active is true, our shader will, let's save. Wait, what? Oh, I must have, I selected active over here, so that's overwriting it. If we do that, it will set it back to what it was before. But if active is true, then it will use our white color. If it's false, then it will just default to the previous color like we set up here, right? And we can easily come over here to our shader parameter and turn it on and off and watch our character blink white like that. So this is a really simple shader. Hopefully this kind of helps you get started with shaders. It's not too complicated. They are a little bit weird at first, but once you start to think of it as that this little program right here gets run on every single pixel, and you learn a little bit more about getting return values and stuff, it's not too bad. Godot also has a visual shading language, which is pretty good, but I tend to prefer just programming and not using visual languages personally, visual scripting languages, but you can try that out if you want to instead, if you want to give that a try. Now that we have this set up, we can come back into our blink animation player, and we'll set our start animation to loop here. And on the first frame, we click on our sprite, we can key active as true. And then our next frame, we can uncheck active and key that. Okay, so now if we run this, our character blinks, just like what we want, right? And we want to come to our stop animation, and on the very first frame, we'll just key active as false. There we go, we'll save that. Now we can come into our player script, and we can get access to our new animation player. OnReady var blink animation player equals blink animation player, like that. Let's clear this, get rid of our output. We can come down here, and once we could set the blink animation player here manually, but if you remember, inside of our hurt box, we actually set up some nice signals. Invincibility ended and invincibility started. So let's use these to activate our blink animation player. So double click on invincibility started, connect that to the player. And you'll see they're already connected, but they're actually connected to the hurt box itself. So now we're connecting them to the player. And inside of here, we can say blink animation player dot play start. And then right here, we'll say blink animation player dot play stop. So it'll start blinking once we trigger the invincibility, and it'll stop once our invincibility is over. And there you go. It doesn't actually trigger for our bats. So let's, I actually want to give the player just a little bit more invincibility too. Let's do 0.6 here. So the player's got a slightly longer amount of time that the player is invincible. So let's do it for our bats too. And part of the reason I want to do it with the bats is because it introduces a new problem that I think is really important to talk about. So let's bring up the bat here. And inside of our bat, we're going to add another animation player. This is the first one inside of the bat, actually. And we'll just do onReady var animation player equals animation player. There we go. We got access to it. We'll do the same thing where we create two new animations. Start, 0.2. New stop, make this in 0.1. There we go. And now that we have those, we can come into our animated sprite, come over, and we can do a new material. We'll select shader material, click on that. Where we have a shader here, we can just come drag our white color shader
and drop it right here. And then we can get access to the shader parameter here, and we can come down into our animation player. However, when we click on the animation player, it gets rid of all the properties that we need for our shader parameter, right? If we click on the animated sprite, it then gets rid of our animation player. So you actually have to click down here on animation while you're on the animated sprite. That way you can have access to key the values here. So for start, we'll activate it and key it. Then go over one frame and key it off. Make sure to set this one to loop. And for stop, we'll just key it as off, like this. Okay? And we'll come into our bat's code here. And when the bat gets hit on hurt box entered right here. Oh, this, good. This reminded me of something actually. Okay, I just don't want to forget about it. But what we need to do here is we need to do hurtbox.start invincibility. And for the bat, we'll do 0.3, I think. 0.3 should be maybe 0.4 for the bat's invincibility. And so we're starting the invincibility on the bat when it gets hit for 0.4 seconds. And then we can come into our bat's hurt box. And we can connect those same signals, invincibility started, and invincibility ended, to the bat. And we can do animation player.play start, animation player.play stop. So we're linking our linking the blinking to the invincibility frames. And so I've just decided to do that. You don't have to do that. But here's the problem that comes up. When I hit one bat, they all blink. They all blink. Watch. So why is that? Why do they all blink? Well, Godot actually shares resources through scenes. So we've got our bat scene here, and we've got our animated sprite, right? This sprite is shared between all the bats. If we make a change to this sprite, it will change all the bats. That's the same with our shader. So if we activate the parameter here, it will activate it for every single bat. And that is done as a way to optimize your game, right? Obviously, if you can share a resource, if the resource doesn't need to be unique, then you want to share that resource to optimize your game, so you're not wasting that memory. So if we come into here though, inside of our bat's animated sprite, we can see that there is a resource drop down here, and we can click on that, and we can check local to scene. And what that means is that it will actually create a new shader for every single one of a new shader resource for each of these bats. It will instance a brand new one. That way, when we activate that shader, we get it only one of the bats blinks, because the shader is local to that bat's scene. And that's a really important thing to know and to understand, so that you are able to use that, right? By default, it's good that this is turned off, but there are certain situations like this one where you want it to be on, where you want them each to have their own copy of the shader. So the other thing that I wanted to do, and this is really good, I forgot about this. Somebody else noticed this and made a comment about it. But inside of the player, when the player takes damage here, we're actually still just subtracting 1, which means even if the bats did 2 damage, the player would still only be subtracting 1 health here, which is different from our bats, which is saying area.damage, right? Which basically gets the damage amount on the hitbox, because the area is the hitbox here. So inside of our player, we need to do status.health minus equals area.damage. And remember when we actually had this underscore here? Remember when we had the warning? If we'd actually looked at our code here closer, that warning would have said to us, wait a minute, you're passing in a hitbox here that has a damage amount, but you're not using it. And so warnings like that can actually help you to find issues in your code that aren't necessarily error messages, but could potentially be bugs still. So even though these warnings can sometimes be annoying, we can always come and add and ignore when we need to. Like for this one right here, we don't need the area. For this one right here, we don't need the body. For this one right here, we don't need to return a value, so we can ignore both of those. You can see it adds a little comment to make sure that it's ignored. And then when we run our game, we should no longer get any messages like that. And now our player should be able to take more damage if the enemies deal more damage to us. So that's going to be it for this series. Man, I really had a lot of fun with this series. I learned a lot, and hopefully you guys learned a lot with me as we were going through it. I'm excited for future content here on my channel. I'm going to be doing pixel art content. I'm going to be doing Godot content. Here pretty soon. I'll probably do some more GameMaker content because of the new GameMaker update that came out. It's still in beta, so I'm going to be waiting a little bit because not everyone has access to it and such. But once everyone gets access to it, then I will be making content on that, the new version of GameMaker as well, because I'm excited for that. I've got a lot of stuff planned for the channel, and I really appreciate all your support, especially to the people who have supported me on my 1-Bit Godot course, the Kickstarter backers who initially did it, and everyone else who has supported me since then. It has really helped me to get my business back on its feet again, because there was a time there where I was tapping into savings in order to keep doing this. So, but I'm back in the black now. We're doing well. Thank you so much for that support. And if you're interested in supporting me more, I do have a Patreon. I've also got the 1-Bit Godot course. You can check out those links in the description and at the end of the video, and I will talk to you all later.